Всем привет! Я надеюсь, что для тех, кто пришел сегодня на конференцию, день проходит отлично. Меня зовут Алексей Акопян, я член программного комитета конференции, и сегодня рад представить вам нашего специального гостя. Его зовут Kwong Tung. Tung — это имя, Kwong — фамилия, но он предпочитает, чтобы к нему обращались как Kwong. И я сейчас переключусь на английский, потому что у нас будет выступление на английском языке, и дальше мы поговорим про нескончаемое путешествие гитопсной трансформации с Flux. Hello, everyone. Hi, Kwong. I'm very
Hi.
pleased to have you on our conference. And from the very beginning of this conference, we, as a program committee, are trying to get not just local speakers who are definitely very good and influential, but as well some influencers on the DevOps culture across the globe. And I just would like to say that on the historical line, you are in a very good company, because some time ago we had John Willis, Jen Kim, Patrick Dubois, and other folks who made the culture of DevOps the way it is now. And I know that you are also putting a lot of efforts to propagate the culture of DevOps and across your part of the world. So how are you today, Kwong? Do you feel excited about being connected to the Russian engineering society?
Hi, yes, definitely very excited, very nervous also. But as you said, I think I'm in good company, so probably calms me down a little, but yeah.
All right. So are you ready to start?
Yeah, sure.
Okay, then just a last thing which I would like to sound before we start. For everyone who is listening us, please come join our dedicated Telegram channel and place your questions in there in the written form, so we can take it back to Kwong after the talk. And it's okay to formulate a question in English or Russian. If you will put it in Russian, I will translate it for him, and then if needed, we can translate it back. I will also work as a translator here for today. Much more than an expert, probably. So let us start, and Kwong, the stage is yours.
So thank you. So hi everyone. As introduced, I'm Kwong. I'm from TalkUp. I'm a DevOps engineer there, and today I'll be talking about in TalkUp our never-ending journey of GitOps transformation with Flux CD, or something that is very close to my heart, which is democratizing infrastructure. So throughout this talk, I will talk about like some issues we face, some introduction on GitOps, Flux CDs, and of course, as the theme of this conference is, definitely some screw-ups. So a little bit about me. I'm a DevOps engineer at TalkUp. I graduated year 2022. I contribute to open source software developed in Django and Angular. So that's why a lot of stuff is written in Python. Yeah, and I also code the Malaysia Land Public Transport Fans community site, which you can see from there. So before I start, just some disclaimer is that first, I don't represent or work at Weaveworks or Control Plane, nor I'm a Flux maintainer. I just contributed a few lines of documentations, and that's all. Yeah. So second is all views represented here are mine and don't represent any other entities, including TalkUp. And third is definitely I'm still a novice. I'm not an influencer as introduced. So the stuff presented here are accurate to the best of my knowledge. So if there's any discrepancies, yeah, please do correct. Okay, so before I start talking about GitOps, right, let's just look at Kubernetes generally in a nutshell. So the typical way of doing things in Kubernetes, right, is that I don't care as long as, right? So I don't care where I do the storage as long as I have like 20 gigs in the storage. I don't care how I schedule stuff as long as I have like a pod that has how much CPU, how much memory, so on and so forth. Um, I don't care which traffic goes where as long as 10% goes to new version. And in the case of like blue-green deployments, I can like define all of them, right? And also the traditional way of doing things, right, is this thing we call kubectl apply and forget. So what we do is we create a YAML file at one side and then we lint it. Do you lint it? Definitely run kubectl apply on it. And then we pray that it works. And if it works, we probably chunk the YAML file somewhere, hopefully in version control. Which let's just hope it works, right? So yeah, as time passes, right, we realize that okay, changes probably will pile up, and you start to ask yourself and probably your teammates around, did I apply this? Why is it here? And then if I apply it, where did I apply it? Is it in staging? Is it in production? Is it in some other dev environment? When is it? And then probably asking yourself, I thought I deleted this. Why is this still in my backup folder? And does this change ever reflect the cluster state? Because us as DevOps engineers, right, we sometimes directly touch the cluster ourselves. So in the end, we don't know what is being done where. And finally, what happens is that we spend time and then we do kubectl get to validate all of the problems I said above. And the problem is, right, I think that we are putting too much trust on people. We tell our devs saying that okay, we should commit in source control after we do the change, but people will say that okay, I'll just trying to fix production first. Let me fix it first, and then after that you spend time asking yourself, hey, I did this and that, right? Well, you start to ask yourself. So one thing that I usually tell people, right, because the second hardest thing of our job is to describe what we do, right? What does a DevOps engineer do? So the first thing that we tell people is that we maintain infrastructure, and then we be the first line of defense when shit hits the fan, and then most importantly, we edit YAML files, right? So it's very, very important that our files and cluster is what we say what it is. And as an inside joke that we usually say, right, we are not DevOps engineer. We are basically like YAML engineers. We just edit YAML files in the end. So from now you can see that we treat our YAML files as the holy grail, and in some sense they are the most important parts of our careers, right? So this company came out called Weaveworks. So year 2015, they created this thing called Weave Cloud to help people manage Kubernetes cluster. Year 2016, then they destroyed their entire production cluster, but due to having really, really good practices, they managed to restore everything in 40 minutes. And after they refined everything, they started to coin the term GitOps. So what are the core principles of GitOps, right? The first thing is definitely declarative. So like the entire system has to be described declaratively. So what does this mean? So remember from the first slide, I said that as a DevOps engineer, we don't care what happens in the middle as long as the final result is what we want. So this is what declarative means. In the grand scheme of things, only the final result is important. I said that, okay, I want a deployment that has 20 replicas. I don't care how many replicas you delete as long as I have 20 in the end, right? The second thing is version and immutable. That this desired system state is being versioned in Git. And from there, we can trace who did what when. And the third is that those changes are being pulled automatically. We don't have something like a schedule that says, okay, this will be pulled like every 20 minutes or so, such that when we see the cluster, we will think back the first question that we ask ourselves, is this thing applied or not? Or is this thing deleted or not? As long as it's being defined in Git, then we will assume that it is already being applied. And because of this, we have this fourth principle called continuously reconcile. So we will have agents that stand inside the cluster to ensure that it's correct, and if it's diverge from the state that we want it to be, we will get alerted, and in most cases it will be reverted back to the state that we declared it in Git. So there are many tools. One tool that I like is FluxCD. We also apply FluxCD in our cluster at TalkUp. So as you can see from the slides, Flux is a set of continuous and progressive delivery solutions from Kubernetes that are open extensible. It runs using the GitOps toolkit, or we call it GOTK. It's a pool-based pipeline. I will talk a little bit more about pool-based pipeline in a bit. It's a CNCF graduated project, so you will know that Flux is, I would say, in good hands. It's released by Weaveworks, now managed by Control Plane. Story at the end of the presentation, and it's now on version 2. So you know that it's being reconciled, and the API is kind of stable and what we want it to be in the production workflow. So let's talk a bit about push and pull pipelines. So in usual cases, right, push-based pipelines, it potentially expose credentials out of a cluster. If you can see here, let me just turn on the laser pointer. As you can see here, we trust the CI with all of our credentials. So the CI will apply stuff into the cluster. So for example, we will have Kubernetes keys that we push into the CI, and then the CI will use these keys to authenticate itself to apply stuff into the cluster. So that's why having a push-based pipeline, right, is a very commonly known attack vector for production, because you don't need to hack the cluster, you just need to hack the CI, and then you will gain access to many keys that can help you gain access to many clusters that you probably will know about in the end, right? Whereas on the other hand, pull-based pipelines, it works within the trust domain of the cluster. So what does this mean? Is that instead of the CI controlling the cluster, the CI just controls the image repository, as you can see here, and then the cluster will pull changes, as what we call the pull-based pipeline will pull changes from the image repository and then deploy it by itself. So we are trusting the cluster to do cluster stuff. Instead, we are trusting CI to do CI stuff, accessing our clusters and apply changes. So in my opinion, I think that this is a much more safer alternative compared to a push-based pipeline. So when we talk about pull pipeline, right, definitely we will have yep, okay. So when we talk about the pull pipeline, right, definitely GitOps, the Flux, the Flux CI is doing the pull pipeline, because I talked so much about how safe it is, right? So what it does is that it watches for code changes here. It looks into the Git repository and everything. The developer makes a code change, put it into Git, and then updates the container registry, and then it will put into the Git config. So in the cluster itself, we will have an operator that watches all of the changes. So we have a deployment automator that watches the image registry for changes, which is in our case it's GitHub, and then it will watch the synchronizer will watch the cluster to maintain its state. So for example, the cluster has like 20 replicas, and then the config says you should have like 5. It will revert all of those 15 ones during reconciliation. Yeah. So a little bit about the GitOps toolkit, where the entire magic works is that the GitOps toolkit, it has a source controller. So it provides a very common interface for artifacts acquisition. As you can see here, the source controller, it can pull from like GitHub, GitLab, and some other places that you define. I don't know what this logo is, but yeah. So it pulls from external sources, and then it will stage it to apply on your cluster. So once the changes are being pulled, the customized controller will take over, and then it runs a continuous delivery pipeline, and then it will make a dry run, assemble everything we customize, and then we'll decide whether to apply it on the cluster or not. Then after that, we also have the Helm controller at the side. As the name suggests, it allows declaratively managing Helm chart releases with Kubernetes manifest. So I would say Flux is a Helm and a customized first application of things. Yep. And the fourth one is something I like a lot. It's called the notification controller. So this notification controller, right, is a operator that specializes in handling inbound and outbound events. So what this does is that this notification controller will, if there's any changes, it will probably notify the customized controller that we have as an inbound change, right? So it tells the customer controller, okay, it's time to, reconcile once. And after everything is done, it can also send an outbound event and tell probably like Discord or Microsoft Teams saying that, oh, something is being done, and then we will get alerted in our channels. So we will know that, okay, some particular change has being done in let's say production, and we will know if something went wrong. And the third is the image automation controller. So if there's any changes that are available, it can provide an update. It can provide the feedback to you such that you can apply it back to the cluster. I have a screenshot later on, so I won't elaborate much on this. But let's talk a little bit about how the commit cycle works. So if you guys come from the previous talk, you'll probably be seen this already, but I'll just go through for a while. So the first thing is, of course, we assume that the cluster has been bootstrapped with Flux. So everything has been set up and everything. And in all cases, Git is always the source of truth. So this is me, right? So when I do any change, I definitely push to the Git repository. Okay, so this Git repository will just stay there, and then my Flux source controller will decide to pull from it. So once it pulls from it, it will build an artifact for revision, and then it will see, okay, do I need to apply stuff? If it does not, it just comes back and the entire thing ends. If it does, then it applies the status for revision to Kubernetes API server, and then tells the customized controller saying that, okay, there's a new revision, please fetch it. And then the customized controller will start to build the manifest and decrypt the secrets. For us, we use the Bitnami sealed secrets because our entire team is, I would say, very young. So we just want something that works for now. Of course, we have SOAP secrets. We have probably like Amazon sealed secrets, secrets manager, sorry. But that is for a future, I would say, future journey. For now, we just use the Bitnami sealed secrets controller for all of our secrets. So the customized controller will validate the objects, then decides to apply it. If something needs to be deleted, then it delete, and then it will wait for everything to be ready. So this waiting can be applied to customize, can be applied to Helm. So in the end, it will update the status, it will emit it to the notification controller, and then it will send alerts like for me or Microsoft Teams, or personally I use like Discord. My company use Microsoft Teams. Many other companies use Slack. So it's just a preference on which part you like. So the image update automation that I talked about just now is that this thing I like a lot is that Flux CD will automatically create a branch with the latest and detected changes. So as you can see here, this is a screenshot from my personal project, is that you can see that I have a prod, I have a staging here. So if there's a new image, it will create a new branch here, and then it will create a PR that says that, okay, there's a new image available. Do you want to merge it? If I want, I just click commit and merge. So it's that simple. So talk so much about Flux CD. Let's talk about some stuff in our production, how we apply it. So here's our scenario. So our product, TalkUp, sorry, the misplaced logo, is a CRM that serves customer mainly in Southeast Asia. So we use WhatsApp Business, we use Viber to connect with customers, which customers will connect with their customers. So for user deployments, we use a semaphore CI pipeline, and then we apply Helm charts. But we are also iteratively removing semaphore CI from our pipeline because due to some image uploading issues, but story for another day also. So the third is when we deploy the GitOps configuration, right, most utility applications are already deployed using Helm charts. So we have Redis, we have Elasticsearch. There is already a very, very basic deployment there already. So from just now, you can see that Flux has a Helm controller. So you can know that, okay, Flux actually treats Helm as a first-class citizen. So that's why we are quite confident on using Flux to do our migration journey. And the fourth is that we have 3 Kubernetes clusters: production, staging, and monitoring. And due to the nature of our business, near 24/7 availability is therefore required. So because of that, as you can see from the picture here, is actually like changing the wheels on a moving truck, which I would say is both exciting and very scary at the same time. Okay, so how did we migrate? The first thing is, of course, make a playground for all of our developers, which is to add a new cluster. We test everything there first, and then we have a GitHub repository targeting that particular test cluster. And then in staging, once we decide everything is ready to push in staging, then we install the Flux controller and GitOps toolkit in staging first. Then we install the seal secrets controller. So the reason for this, right, is that we want to start committing secrets into the GitOps repository. I know probably like declaring secrets and stuff, although it's encrypted, is kind of a bad practice somehow, because if you lose the master key, you lose everything. But we want to progress, so that's how we did it. And the fourth step is that anything already managed by Helm, we just take it over using Flux CD. So what Flux CD does, right, is that if the resource already exists, it just labels it having the Flux controller manage something label. So we also add declarations according to namespaces. Why we chose namespace as I would say as an element or as a chunk of migration is because we want to remember stuff consistently. So for example, we have a namespace like backend. We can ask ourselves, okay, did we migrate backend to GitOps? Yes, no, and then we can proceed from there. So that way we can organize ourselves better, and does not actually defeat the purpose of having a GitOps workflow. Okay, so talking about this, after talking so much, so what, right? You'll be asking me like, when you migrate to GitOps, what happened? So the first thing that we found out is that we have about 100 times speed improvements of cluster recovery. So since the introduction of the GitOps pipeline, the cluster recovery time reduced from like 3 days, which those 3 days, right, basically people will need to sit in front of their laptops and configure stuff from scratch by hand. And we also won't be confident that the cluster state is what we want it to be, because when many people configure it at the same time, there definitely will be some clashes. So because we have this GitOps, we just chunk everything in, and then we just tell the cluster, okay, recover from this configuration. So it just recovers itself, and then we reduce the we reduce the recovery time from 3 days to 40 minutes, and we are very confident that the cluster is the state that we want it to be. And the next thing is, I would say something that I'm very happy about is that because of this change, we actually gave a 5 times infra innovation. So how does this 5 times come to be, right? So previously we have a repository of, I would say, deployments, which patches the cluster. So if there's any changes, it does a push-based operation to the cluster to apply everything in. So if we want to change anything there, right, we will need to make sure that it will work in staging and production at the same time. So we cannot do anything other than those. And this actually slows down innovation a lot, because you can have a bunch of PRs waiting, but no innovation is being done, and we can't progress. Everything is being blocked, and everyone is frustrated because they will remember the PR that they done like 3 months ago that haven't merged, right? So from 2 to 3 changes in a month, and then we are able to do 3 to 5 changes in a week for infrastructure. So I think for infrastructure as a whole, and being a small company as us, I would say it's quite an achievement. And also because of the GitOps way of doing things, right? We can queue everything and iteratively apply. So we can tell, like for me, I can tell my senior saying that, okay, now all these changes can be done. Good night. Let me just go and sleep, and then she will change it at her time, right? And this is very important because we don't need to wait forever for maintenance window to do changes anymore. We just apply, and then, for example, if we want to test locally, we also just apply the entire GitOps infrastructure to our local, I would say, Docker Kubernetes. Although there are some configurations that still need to be done, but it's very, very easy now. And the second thing is something that is very, very close to me, to my heart, is that to democratize cluster management by involving juniors. So as you can see, I came from a junior and slowly became a DevOps engineer. So the thing that I always tell my senior is that, okay, please let me touch the cluster, please, pretty please, right? And then my senior is like, no, you're gonna bring down stuff, and we can't afford downtime. But after having a GitOps, right, we will be very, very confident saying that, okay, as a junior, please don't delete anything. You can do some changes, but just do this particular few things, and then after 10 minutes, everything will just go back to where it is. And we can actually test on production, although it's still not recommended, but we can test on production, and we don't need to be afraid that our cluster will randomly explode or make untraceable changes, because in the end, we will know who did what when. Okay, so talking about metrics, talking about experience. So no experience is complete without breaking production. So here's a story about how I brought down production twice and some lessons learned. Okay, lesson number one, always log versions for production. So during migration, right, I copied the configuration directly from staging to prod. So you can see this particular line here is the culprit. So when there are updates to the Helm charts, they are done and merged for testing in staging. Production automatically updated itself. So for example, I updated 0.3 point something. Production is having this same configuration. So it says, hey, there's a new version, let me upgrade myself. So this resulted in the outage lasting for about 15 minutes. Boss was definitely not happy. So lesson number one, always log versions for production. Lesson number two is also a very, very idiotic, I would say, thing, is to always use Control F while making changes. So, it's very normal. Humans make errors, right? So I accidentally modified the prod image targets instead of staging. So the thing that's supposed to go into staging, I put it into production, which luckily with GitOps, we just roll back the entire commit, but we have some routing changes that are already partially done. Good thing there were no database migrations at that time, which led to the outage lasting about 5 minutes. And my senior was very, very not happy, and I kind of lost production access for some time after that. But yeah, I kind of deserved it. So yeah. Okay, so more lessons learned. So first thing, we should have started way, way earlier. The earlier we incorporated GitOps, the better. As what I said previously, anything that can be tracked should be tracked, and you'll know in the end who to point fingers to, right? But the culture is not about pointing fingers, it's about knowing who did what when and what went wrong in the process. Why did this thing pass all of the eyes, right? And the second thing is, when telling my boss, he kind of told me that, okay, go into the SOAP conclusion as soon as possible to let them have a very, very high level overview, because I started telling my boss and my senior, okay, we need to do GitOps. They're like, okay. So I kind of spent a week preparing a document on the potential benefits that that we will have after we implement the entire GitOps pipeline, that they are happy to, in the end, have accepted and implemented throughout the entire company. And the third is to dig into existing configurations as much as possible to reduce dependencies between the declared and the actual one. So, so because of some bad practices, right, we previously have things that have secret targets from env from, and we have some secrets for some reason are passed manually. So it's being pasted directly into the environment file, and we almost did not catch it. So good thing that we do kubectl get for the pods and the deployments to finally get a picture of the entire infrastructure. So it takes a lot of time, but don't worry if it takes like 20 deployment cycle to fully roll everything out. Just be right on the first try, because in the end, you are talking about infrastructures, right? It affects everyone. And the fifth thing is like people that are starting out, of course, definitely install a GUI dashboard from the start to help sort out deployment errors during migration. So when you migrate, right, you don't know what commands are there existing. So for example, right, you know kubectl when you deal with the cluster, but you don't know that, okay, Flux has their own CLI tool that you can view from the Flux point of view. So it's kind of different from kubectl, but it gives you a better understanding of what is happening. So if you install a GUI dashboard, all the thinking is being done for you. So you just so you don't need to do the mental gymnastics of converting things all over and over again, or go into Stack Overflow. Everything is just there being displayed on, I would say, a dashboard. Okay. Also, some things to consider if you want to implement like GitOps generally in no, sorry, not GitOps, sorry, implementing Flux CD in your cluster. The first thing is Weaveworks ran out of funds late 2023, and then after that shut down. So at that time when we saw this news, we were like, oh my god, we already implemented like our entire infrastructure on this. What happens next? So the good thing about CNCF and the way they do stuff, right, is that they have funding, and many people are eyeing the CNCF space and the GitOps space, right? So after a few days, this company called Control Plane, they took over the project. So they employ Flux maintainers in the process to continue its development. And one thing that I'm very happy about is that Flux is growing now at a very, very high velocity compared to previously, which is also a lot nicer. And because previously, Weaveworks, they kind of locked away the GUI behind the paywall. After Control Plane took over, many parts of it kind of opened up, and community contributors started to come in. So I think this change is, I would say, good in the long run. Okay, so yes, I saw someone asking about Argo CD. So yeah, the question will be definitely why Flux CD and not XYZ, especially Argo. So the reason we did this is that we are using Flagger from the start. So Flagger, right, is like I would say came from the same Flux CD project. So I figured that, okay, since they're from the same project, they should work well together, which in hindsight, they do not work well. But yeah, since we implemented it already, why not, right? The second thing that I thought of is that, okay, Flux CD looks kind of way more bare bones than Argo CD. So simpler probably equals to better, which means better debugging for us, probably. But yeah, during the implementation, which is about 1.5 years ago, I was like quite new to this entire thing. So we decided that, okay, something simple is better. I don't need to really remember everything. So yeah, Flux CD it is. And the third thing is easier dev onboarding from the YAML side, because like we are YAML engineers, we work on YAML files, and also it's kind of a way of us gatekeeping stuff a little. So I know this kind of is against what I said just now, but we will really want people that actually understand YAML first before they touch anything related to the cluster. So it's a very small gatekeeping step to make sure that people that touch it know what exactly they are doing about. So yeah, So in a nutshell, why GitOps? First thing, increase productivity. As I would say, we can apply a lot of changes very quickly. Auditability, we know who did what when. Reliability, which means that we know that this particular configuration in the end is, when we apply it back to the cluster during a recovery, we know that, okay, we can directly apply and this is the final thing. Second thing is enhance developer experience, democratization of development, which I emphasized a lot just now. We let more juniors get into the entire thing. And third is stronger security guardrails. We don't do kubectl apply anymore. We just apply to Git, and then when we decide to merge, that is the time that we apply. So we let more people work on the cluster without them directly touching the cluster. So in this sense, I would say it's a stronger security guardrail. Fourth is faster development, better operations. Like I said, yeah, everyone can work on the same thing. And the fifth is definitely easier compliance and auditing. So same thing, who did what when, right? So I guess that's my talk. So thank you everyone, and do connect with me. You can scan the QR code. You can come to my GitHub and find me, or find me at LinkedIn. Thank you everyone very much. Hope you have a nice afternoon, I guess.
Thank you, Kwong. Thank you very much. And we do have some time actually. So I'll probably go and ask a couple of questions which we got in the Telegram channel. And
Yep, sure.
I would also like to encourage everyone who's listening us to add their own questions, so we can also continue in the discussion zone. And so first question is, why do you need to update the infrastructure settings several times a week? Is it because your product is still evolving very highly or unstable, or is there any other specific reason? Because it sounds like infrastructure settings are probably not supposed to be changed that often.
Yes. So I would say, like, when the product was initially being done, we had this idea to push it to the market as fast as possible first, to actually have a working prototype first. So there were not a lot of thought on how is it in the end. So for example, we have the recent outage like Redis. So when we applied Redis, the first issue with Redis is that we didn't know that, okay, we can actually apply, we didn't know that, okay, we need a separate URL to access the Redis replicas. So in the end, we thought we have 3 replicas, but actually everything was targeting the master node itself. That's the first thing. And the second thing is, we didn't know that, okay, like Redis Sentinel exists at that time. So because the way that our company looks on innovation, we actually welcome it a lot, especially after the implementation of this GitOps, right? We decided that, okay, if anyone has any ideas, just probably do a POC, submit like a PR or something, and then we'll work something out. So for example, one recent thing that we are going to do is we are going to switch to Valkey. So I can expose a little, is that during the next deployment, we'll be switching to Valkey. We will be doing some changes to our Helm chart. So before this, when we do the declarations on the Helm chart, if you're familiar with workers, so things that run in the background, all of our workers were declared explicitly. So we have like 16 worker declarations. So there are 16 different files. So we will need to consolidate everything in. So in the end, why do we need to update this? Is because when we work on things, right, we will find new and better things to implement them. So having this kind of spirit, I think, allows things to, I would say, evolve much more quickly and more stably.
Okay, yeah. Thank you very much. And I got a feeling that during the first years of your product, you definitely were not the only one junior who was disappointing the seniors by breaking up the production somehow.
Yes, definitely.
And actually, it would be. I think that we might be also curious to learn about other interesting stuff because obviously we are learning from our own mistakes, but we are also learning from others, even without disclosure. But
Yes.
we do have more questions, so let me
Mhm.
continue, and we probably we still have time for questions. I don't see why can't we do it
Mhm.
on air. What were the reasons given by your seniors against implementing GitOps? This is a very good question because
Mhm.
when some junior engineers comes up with an idea, the first is okay. This is a junior and it has ideas. What should we do? So what were the arguments which have been given to you, and maybe how did you come up addressing those?
So initially the reasons were like, okay, because when I joined the company, right, I was as a backend engineer. I wasn't really as a DevOps engineer. So
Mm-hmm.
I joined since my intern, and I kind of told my boss at that time and saying that, okay, please let me touch Kubernetes or I won't join this company. And he says like, oh, okay. But after 1 year plus, he's like, ish. So they were trying to push out different features, and they need devs to do that instead. So they were thinking that, okay, instead of giving you time to figure out this, let's just push features first. So the kind of my reason at that time was that we need people more on the different side. So at that time I also didn't really wait for my company to do it. I applied it on my home cluster. So I actually run a small Kubernetes cluster at my house, and all of the experiments were being done there. So that's like 1 year, half to 1 year after I did on my own cluster. I figure out that, okay, it's stable enough. Then I only propose to my bosses.
And it worked immediately.
Not immediately, but eventually it worked out. I think the entire process took about 2 to 3 months.
Mm-hmm.
But yeah, I think it was quite necessary for everything to be stable and progress as we want it to be.
Got it. Thank you. I have a quick follow-up on this.
Mhm.
But was your boss, your immediate boss, the only person you have to, buy into GitOps approach, or you also had to negotiate with other folks, like other engineers, maybe in your team or outside of the team, because in general,
Mhm.
introducing GitOps requires cross-team collaboration, and
Mhm.
just getting support from your immediate boss in some situations might not be enough.
Mhm.
Can you maybe share at least how would you approach if you didn't face it yourself? Because many of our audience might
Mhm.
be in the situation like that.
Mhm. So one thing that I would like to highlight is that because I started as a backend engineer, so we had this thing called migrations in Django. So what this does is that it does some database changes. So the problem with backend development is that I don't know if it's a process error on our side, or is it in generally, is that when we screw up the database, we need to start from scratch, and there are a
Mm-hmm.
lot of configurations that we need to do it manually. So at that time, I told my seniors, I told my boss, and saying that, okay, just give me 1 week. Let me just create a script first. So I started with creating a script. They realized, oh, this thing works, and then I started creating more and more scripts. I would say we call it DevX, developer experience stuff. And then that was also at the same time I tried to convince them on the GitOps stuff. So all of this actually run in parallel. So once they are more confident on the DevX stuff, then they slowly buy in on the GitOps stuff. So
Uh,
as long as you can, yeah. So as long as you can kind of prove to your seniors and bosses saying that, okay, spending 1 week of this will save people 3 hours a day, then they would definitely buy it in already.
Sounds good. Sounds good. Yeah. So you typically made your code speaking for yourself, and this is definitely a very good thing. I think that we have like 5 minutes before the end of the session. So let me pick up one more question in that session, and after that, I would suggest we move into the discussion zone. And it's the question from Kirill about observability or alerts, based on Flux CD events. Do you use them? And if yes, maybe in which situations, and did you have any issues or challenges with that?
Actually, not much challenges. Because it's just like I would say just a YAML file. I just declare everything in there, and then like for me personally, I use Discord, so I just declare my Discord webhook there, and then if there's any events, it just fires there. And then for my company, we use Microsoft Teams, so each cluster will have their own channel, and stuff will just fire there. One of the things that we face, right, is when we use something, I think it's called Amazon Cloud Link or whatever. There was this particular namespace that is very peculiar that keeps running out of sync. So every 10 minutes you have one notification saying that, oh, this thing has been reconciled, this thing has been reconciled. So in the end, it results in a lot of background noise. So what we did is that we filter off the notification. So yeah, Flux CD, you can do that. You just filter off based on namespace or the message content, and now everything is just clean and very nice. Also on observability, we don't synchronize that frequently on our cluster, so it's not that important. But Grafana, I think Grafana has a chart that is built for this already.
Okay. Thank you very much.
Thank you, everyone.